Hey, hi everyone, this is Phil from statisticsmentor.com. We're going to be looking here at an example of a test of association, otherwise known as crosstabs analysis or chi-square test. And it's something that's taught on introductory courses. It's similar, the idea is similar to correlation. The test of association is that we want to see whether there is a relationship between two qualitative variables. In this example, I've got employment data. I have employment and degree, and I want to see if there's a relationship between employment and degree. Degree is the type of degree studied by a student, and employ stands for employment expectations, whether they're high, modest, or poor. And the count here is the number of people falling into the particular combinations of the two variables. So for the first one, we have high employment expectations, and students did social science degree. 12 people fall in that category of studying social science and have high employment expectations. Second one is we have 27 people who have high employment expectations who did biological science, and so on. Now, being a test, we will need to know what is the null and what is the alternative hypothesis. The null hypothesis is there is no association between employment and degree. In general, the null is there is no association between attributes A and B. Now, we can say this variously. We could say this as that employment is independent of degree, or we can also say as there is no relationship between employment and degree, and the meaning is as it sounds. So there is no kind of pattern between the degree and the employment expectations. The alternative is the opposite, which is that there is association between employment and degree. Now, students typically get these two the wrong way around if they do get anything wrong at this stage. It's easy to remember because the null hypothesis begins with N, and also null stands for nothing. So no association rather than there is association. Okay, N for no association. The data here has been aggregated, so instead of listing 12 separate rows of high, social, so all the way down 12 times and then 27 of those, we've kind of aggregated them. So we've got this counting here. So some of you using other packages like SPSS will be looking at this and not recognizing this, because in SPSS you'd have this like 12 times and this combination 27 times and so on. Right, so to run the crosstabs analysis, to test that hypothesis, this formal hypothesis, there's no association between employment and degree, we run, the command is xtabs, open bracket, the frequency, which we call count, tilde, and then the two variables, employ and degree. Right, I'm going to put that into an object, call that object called res, enter, and then we look at the results. And what is printed out is we're told that there are 300 participants then spread across each of these 12 cells, 12 combinations. Two factors being employment and degree. And this test for independence, which is what we want, the chi-square, which is why it's called, also known as chi-square test. Chi-square is 61, about 61.5 on a 6 degree of freedom, and the p-value for that is a very small number, 2.2 times 10 to the minus 11, so it's pretty much 0. So what we say is that since p is low, it's less than 0.05, indeed it's less than 0.01, we can reject the null. Moreover, there is very strong evidence to reject the null hypothesis of no association between employment and degree, in favour of the alternative, which is that is an association between employment and degree. Now, having been able to say that there's an association, I want to kind of discuss more about the nature of that association. So to get that, we use the chi-squared.test command. So the format is chi-squared.test, and the results of the crosstabs put into there, we'll call it something called ZZ. And then if we look inside the object ZZ, we can look at the observed values. Oops, I spelled that wrong. Observed values, so ZZ, and then dollar to say we look inside that ZZ object to look for the observed. There you go. So degree social, biological, physical, arts, employment, high, modest, poor, 12 people observed to have, out of 300, did a social degree, had high employment status. So in this table is the same as this thing here, but just differently formatted. Okay. We can also look at the expected counts. These are the numbers that you would expect if the null were true. So what this says is that if the null was true, if there's no association between employment and employment expectations, you would see about 20 people who did social science and had high employment. So here the expected value is higher than what you actually observe. The idea is that if the null is true, the numbers of the expected values for each cell should pretty much match. Theoretically, if it was true, the null was true, it would match exactly the observed counts. So the test statistic would be 0 rather than high value. Now, while we're on this theme here, the expected cell counts are also important because to run a crosstabs analysis, we cannot accept any cell count. We cannot accept if we have more than 20% of the expected cell counts, which take the value of less than 5. So since we've got quite large numbers here, we don't have anything remotely near 5, so we're fine. If we did have more than 20% of the expected cell counts less than 5, we would have to combine groups. So that's one way to deal with it. Now, another way to see differences between the observed and the expected is to look at the Pearson's residuals. Pearson's residuals is the signed square root of the contribution of that cell component to the chi-square test statistic. So the chi-square statistic is of the form, sum of observed minus the expected, all squared, divided by the expected value for that cell. So here we're looking for values far in absolute value from 0. What we can see is that this one is the highest one, and that corresponds to art students that have poor employment expectations. Now if we look at that more closely, the observed is 33 for that cell, but if the null were true, you'd expect 14. So what you observe is higher than what you would expect. In other words, more art students than you'd expect have lower kind of employment expectations. Next one, largest in absolute value, is this one here. It's a minus figure. So look at that. Physical science with poor expectations, what you observe is 3, and if the null were true, you'd expect 15, so lower number than you'd expect if the null were true. Physical science students observed to have poor employment prospect. And the next high one is this, again for physical science students. What this points to here is that basically physical science students tend to have higher rather than lower, higher on average expectations of a high employment prospect. Okay, so we'll end it there. So we've looked at a very basic introduction to test of association. The null is that there is no association between two qualitative variables, and we use the chi-square test to see whether this is true. If we reject the null, we then look into the table to see what kind of patterns that we can see and report. Note that this test does not indicate the strength of association, for that we need another test. All this test does say is the evidence, yes or no, of an association between two attributes. Okay, so that's it. Hope that's been helpful.